Hey everybody. So the next thing we're going to discuss here are the features of epithelial tissues. So these are some features that all epithelial tissues do have in common. We can start off with the fact that they are very tightly packed together. So that's something you're going to notice. So with that said, you're going to see tight junctions as well as desmosome bonding points because of these tightly packed epithelial cells. Usually, we're also going to see these cells existing in sheets or in layers. And for that, we'll see more example of that in just a minute. But because, like we said earlier, one of the functions is that they are usually lining different tissues. It's important that we have multiple layers so that in case some of them get scraped off the top, we have existing layers underneath it. Again, so because that's one of the protection attributes. When it comes to looking at these cells, it's important to understand that there are different polarities to these cells, meaning that each side of the cells have different appearances and features. So polarity, again, think of it like the poles of the Earth. You have the North Pole and the South Pole. One's on top, one's on the bottom. All right, depending on which way you're looking at, I guess. So with that said, if we are looking at the North Pole or the upper end, this is known as the apical side of the cell. So this is going to be the top. The way I remember that is A is the top of the alphabet. Usually, when you're looking at the apical end of these cells, we're going to see features that are associated with it. Some of these may include microvilli, which are going to be these little structures here. All right. Their job is to create surface area, right? So think of it as if you have a tissue, right? Or if you have something like a piece of paper, right? If you have a piece of paper, what you can do is you can crumble it up so it takes up less space, but you still have the same amount of surface area. It's still one solid sheet of paper, right? So if I take this sheet of paper and I roll it up or crumple it up, excuse the loud noise here, what happens now is it's still one piece of paper, but now it's in the shape of a ball. It's a much smaller object with the same amount of surface area. That's what's going on with things like microvilli, right? So it is a cell and it is compacted and it's in a wave shape so that it can fit a ton of surface area in a small spot. Why would we want high surface area? Structures like these are going to be used for absorption of various objects and materials. So that's the apical end. So the top end, we're going to see things like that going on. Another name for that could be the brush border, all right, because it kind of looks like a brush. So another thing we may see are things like cilia or flagella on those sections. Here's another image here. It's kind of hard to see, but you can see that at the very top of these cells, we can see the cilia, the top here. So if we have a top, there must be a bottom. So the basal layer is the bottom layer. That's the way I remember it, B and B. So the bottommost layer of the epithelial tissue is always attached to the basement membrane. Think of it like a house, right? The apical end would be the roof. The basal end would be the basement. The basement is attached to a foundation. That way your house doesn't just, you wake up in one town and then you go to sleep and you wake up the next day in another town because your house is rolled away. It's not how it works. It's attached to a basement, also known as a basement membrane here. All right, so this is going to act as a barrier between the epithelial tissue and the underlying connective tissue. So underneath these epithelial tissue, we're going to have various connective tissues. So this is going to be what connects those epithelial from the connective. If you don't believe me, think about your skin because we have mentioned this. There is epithelial tissue on the top of your skin, and that skin is attached below. Grab on your skin and give it a pull. Hopefully it doesn't peel right off, right? It's because it is attached via these basement membranes. Epithelial features, continuing with that, let's talk about the basal membrane in a little more detail. There are actually two sections to the basal side of the cells. The basement membrane is divided into two parts, an upper and lower layer. So we have the basal lamina and the reticular lamina. These two things together are what make that basal membrane. The basal lamina is the upper part, and it's going to be the closest part to the epithelial tissue, and it is going to be secreted by the epithelium. Underneath it, we're going to have the reticular lamina, which is going to be attached to the collagen fibers below. So again, this is what's going to allow for the basement membrane to, one, attach to the connective tissue to keep it in place, but also connect to the epithelial tissue. This is a fair picture. It's not the best one in the world, but what you can see here is the basal lamina, which is on the top part. This little, like, it looks like a sheet, and this sheet is connecting to the epithelial tissues above, epithelial cells above, as well as to the reticular lamina below. So it's kind of like that in between that connects the top and the bottom together. So what you're seeing here is that it's not as simple as just one structure, right? It's not just one thing. There's many components that make this up. And I'll draw this out really quickly, even though it's, my drawing is not amazing. But what we can see here is, let's see, the epithelial tissue is at the top, right? And here, I'll show you guys this too to help you out, right? We're going to see the basal layer at the top, or the epithelial tissue at the top, and then we're going to have our basal lamina. This makes sense now, does it? We're going to do this. All right, we're going to have our basal lamina. It's going to attach to the epithelial cells, and then right below it, we'll have the reticular lamina. Connecting to that. And then lastly, the connective tissue. Couldn't think of another fun shape for that. So the epithelial tissue is at the very top, as we see here. That's going to be connected to the basement membrane, which is this whole section here. So both of these things together make up the basement membrane. Okay, and that is what's going on here. So the basement membrane attaches to both connective and epithelial tissue. Specifically, the basement membrane is two parts, basal and reticular lamina. All right, and the last thing before we move on to the next slides is a couple other features. Number one, they are avascular, meaning there are no blood vessels that run through here, which is kind of strange, right? So there's no blood vessels running through here. If you don't believe me, scratch your arm. Some of those cells are going to fly off your arm and you're not going to bleed. If you scratch a little deeper, maybe, but at the very top, superficial layer, those cells are not vascular. Nutrients can actually be absorbed through these tissues via diffusion because they're so thin. And lastly, when it comes to regeneration, they do have a very high mitotic index. If you remember what mitotic means, mitosis is cell division. So therefore, if you have a high mitotic index, you are dividing frequently. Okay, so these cells will divide frequently. So these are some general characteristics and features of epithelial tissue. The next few slides will talk about specific types of tissues, as well as the way they are structured, the way they are laid out.